all of our Java application runs using objects. And so we have to have a good feel for once we create the objects, how do we move them around? How do we manipulate them? How do we make them do the things we want to within our program? So the first thing to understand is the objects live and they're created at some sort of permanent address space. And so the analogy I'm going to use here is like a house. So each house has an address that it's built at. And so, whether it's 2nd Street or the County Road or Pennsylvania Avenue, your house is built on a specific plot of land. Now, the structure of the house is built from a blueprint that's given externally. So that same plot of land could have a bunch of different shapes of houses, or the same shape of houses could end up on a bunch of different plots of land. There's certain neighborhoods, particularly out west, I've seen where every single house looks exactly the same. They're adobe, they're colored the same, they're painted the same, there's the same structure. And so they literally look like the same houses, so you have to pay a lot of attention to what the specific address is. Is it the third or fourth or fifth or sixth house based off of, is it 24, 71, 72, 73, however they're numbered. And so that is really important in code on the computer because the memory location is where the object's stored, and it stays at that memory location no matter what. And so when we're interacting with an object, we're not actually dealing with the piece of land it's on. We're dealing with the address, which is a pointer, which is the variable that's pointing to it. And so again, if I was going to send you mail, I wouldn't go to your plot of land to do that. I would write down this representation of that plot of land, 1600 Pennsylvania Avenue, and then whatever I wanted to mail would be mailed, in this case, to the president. So if you want to work with an object, you have to keep track of its location. Now, when it's built, it gives you that address. It gives you that representation. It gives you a variable. It returns to your variable that information. So you have the object, 600 Pennsylvania Avenue, which is the same as the object we're here creating as a bubble. And then there's the reference, which is the actual address. So there's this big white house that lives at that address, and that's represented to us by, in this case, we're going to draw a picture as a arrow, but the arrow represents a variable that we're going to see. So in Java, the references are defined within a class by using the class name. So when I see I have a product outside of there, I have a product class, and I have another class that's going to refer to that project. There's a relationship between these two classes. I'm keeping track of it, which is the line item. So in a receipt, when I go buy something, I buy 5 cans of tuna. And so when I go buy 5 cans of tuna, the product I'm buying is tuna. And that's the product that was sold. And then there's, on the line item separately, there's a place to store the number that was purchased, which is 5. But here we can see that the name product shows up as the other class that I'm keeping track of, and then I name the variable whatever I want to, which is my relationship to that product, which is the item that's being sold. This becomes really important because when I want to work with an object, I need that reference. And to do anything in Java, I have to work with objects, so I need references. Because objects hold our data, they keep track of other objects, they are the ones I ask to get work done. So again, that line item inside of there is the thing that I'm purchasing. So I have a variable called myPurchase, which keeps track of that line item. And that line item keeps track of the product that I'm purchasing. So you can see this network of objects. That's what forms our applications within Java. So if I want to figure out what's the total of my purchase that I'm making, I can go to the variable myPurchase here, and then I call, using the dot parameter, the dot operator here, the calc total method. So what's this saying is, in the object myPurchase, there's this method called calculate the total, calc total, that will do some work for me. And that method is defined in the class. That's what we saw in that bottom compartment of our class diagram earlier on. So the purchase is the key to this, though. We need that reference. Now, again, it's not the actual object. We don't carry around and pass around and work around the whole property. If I want to talk about who's going to win the White House in election season, I don't refer to I don't literally carry around that whole house. I just refer to its address. I refer to the White House. Who's going to go live at 1600 Pennsylvania Avenue? So that's what we're referring to in all of our Java code. That's really, really important. So you got to remember, objects don't work alone. So when I call that line item, the line item is also dealing with the product class, and the product class, remember, we referred to that variable as being sold. And so when we say sold.getPrice, we're passing along that work. We have this network of objects that do the work. So I want to know how much my total is. I say line item, how much is the total? The total says, oh, well, I have this quantity, the number that you purchased. I'm going to multiply that by the price, which I'm not keeping track of. It's the product who keeps track of that. And so it goes and asks the product, hey, by the way, how much do you cost? And so the can of tuna costs 70 cents, and I bought 5 of them, so now my total is $3.50. So that you can see that interaction between the objects is what gets me my inevitable answer. So in order to have this network of systems, I have to create this network of objects. I have to create it. I have to create them as needed for whatever demand I want to there. And when I create the object, that's where I arrive at the reference to that. So in the memory space of your computer, I will put a line of code like a line item X. It's something I'm about to create. But when I say line item X, that's the same as buying an address book. Just because you buy an address book doesn't mean all of a sudden you have a property that popped into existence. It doesn't mean a bunch of properties popped into existence. It's just a place for you to write down the addresses of people you know or will know. Same thing is true when I define a variable of a class, like line item or string or date, any of the pre-existing or any of the classes you will create or use as part of your Java program. So this variable is created. It creates a space for the variable, but only creates enough space to keep track of another object. So when I say x is equal to new line item, at that point I create the actual object. And x is receiving a location where that object's going to live, but I don't actually get to pick it where it's at. I don't actually get to pick that plot of land. It just takes the next available plot of land down. So it's kind of like if you had this interesting system, you go to the city and say, I want to buy some land. I want to buy a house, and they say, okay, well, the next plot of land is number 7. Then the next person comes down to it. You're at number 8. So you don't get to pick where your house is. You just, it just gets created. But in the virtual world, that's okay. In the virtual world, everything has a lake view and is next to the beach and next to the ski lodge all at the same time. So we don't care about the specific place it lives on memory. But the point is, it lives there, it stays there, and we refer to it, given the variable that is being created. So if I go through and I say new line item, without having a variable for that, then that's okay. I can do that. It just means I've created a house out in the middle of the forest and forgotten where it was. The house still exists. The house is still out there, but I have no way of going to it or referring to it or telling other people how to get to it. It's a little bit of a flaw, but not entirely. There's reasons why you might want to do this in a Java sense, but just not something that happens very often. So the question is, what happens if I have a variable that I haven't pointed to anything yet? We've talked about this a little bit. So when I create a variable, its initial value, if it's an attribute of a class, is null. Its initial value, if it's a local variable, needs to be filled in by you. But if you want it to point to no object, it's null. So again, when you buy a new address book, it comes blank, and the initial value is blank. The blank for objects, the name of that is null. So it's not 0, it's not empty. There's the word in Java, it's a reserved word, N-U-L-L, null. And so when I go through and I point to an actual new line item or an existing one, I no longer point to null, I now point to that object, wherever it lives. But I can go through and set it back to null. I can forget about that object and it goes back to being null. Again, notice here that object doesn't disappear. I haven't deleted it from existence. I'm just pointing to nothing again. And so it's kind of like unfriending somebody. I'm going to take your address out of my address book. I'm going to forget about you. I'm not going to know where you live or know how to call you or anything like that. But you still exist. It's not like you're being wiped out. So the question is, how many objects can live in a Java program? Well, Java programs keep building objects until it runs out of memory. There's no theoretical limit to the number of objects that can exist. There's just a practical limit of at some point your computer's not big enough, or at least the slice of your computer that was given to the Java program is not big enough. So it's in theory, unlimited the number of objects you can create. Practically speaking, you're going to create the objects you need for an application, and hopefully that's less than what you need to live on your server for whatever you have going on. But that being said, Java helps you over time. If you have a program that runs for a long time, it's not like everything needs to live forever. Java has this notion called garbage collection. And so what it does is from time to time, it'll go through all the objects that were created and look at each one of them and say, does anybody care about this one anymore? Basically, is there a reference to this object? And so it'll start at the ones you're using, and it'll say, hey, do you care about this? And if it is, it'll keep it. But if you create one of those objects that nobody's referring to, and there's nobody who is keeping track of it, or there's a small network of objects that keep track of each other, but nobody knows, nobody has any one of those objects to keep track of, at that point, Java says, okay, this can be thrown away now. We don't care about this anymore. The last thing I want to throw at you is this idea of assigning one reference to another using variable, just basically assigning a variable. So normally if I say x is equal to 4, x becomes the value 4. If I say x is equal to 2, x becomes the value 2. What happens to 4? It's, if you will, overwritten inside of there, because x only keeps track of one number at a time. It's not like the number 4 stops existing, it's just I stop keeping track of it. Same thing is sort of true here with an objects. So I have line item x, and I create a line item, and I can create a variable line item I, which is pointing to nothing to start with, and I can say x is equal to y. So now I have two objects that are pointing to the same thing. This is like, everybody in this class has my email address. Anybody in this class can do that. If one of you says, I'm done with this class, I got my AA, I'm leaving, and deletes my email address, it doesn't mean I'm not available for other people to email to. Same thing is here true. By sharing my reference with somebody else, then two objects can keep track of that. But that also means that anything that happens from one object it is impacted by the other object. So if in a line item, if X thinks I'm buying tuna, and Y says, tuna, that's not very manly, I'm going to make it a cheeseburger, then X also now has a line item that is pointing to a cheeseburger. So you have to know that once you share your reference to another part of your program, that part of the program can manipulate your object in ways that it chooses to. It's not like you have exclusive access to the object forever and ever. So that's one of the keys here is when I'm dealing with classes, I have to consciously make a copy of a class if I want to keep a class unchangeable by other parts of the program. It's a very advanced programming concept that maybe you won't come to for a long time. I don't know, it's not covered in the core Java approach here, but the idea of it's called immutability, unchangeable objects. They have to be designed in. It's not like that by default. Some older coding languages had this idea of pass by reference, pass by value, or making things so they can't be changed. By default, when Java works with objects and shares objects, any object can call methods, any objects can change values, and again, since they live at one location, they're all shared. So if I go and paint the White House purple, and it's now the purple house, well, your White House got painted purple too, because 1600 Pennsylvania Avenue got changed, and as much as we all expect it, hey, I changed the color. That again, it's besides from me committing a federal offense and probably going to jail, it does impact all of us. It is a shared object there. All right, so that's a little bit about working with objects, a little bit about how these variables and pointers and all that stuff work. So hopefully that helps you as you start to play with these objects. We'll keep diving in. You'll get more feel for it as we go, but that's the next step to working with Java and objects and object-oriented systems.